Hey, my name's Trevor. I am the owner of Conserve Irrigation of North Houston. I have lived in the Houston area now, North Houston area, for about 20 years, and in those 20 years, I've also owned an irrigation system in my house. And I don't know about y'all, but it's getting darn expensive to keep that irrigation system running throughout the season, keep my lawn green. One of the things that I've learned about as an irrigation business owner is not all irrigation systems are created equally. They're not designed equally. And the question is a sprinkler head a sprinkler head? It's a good question. We assume that if our system's running, we don't have broken pipes or heads spraying water everywhere. We assume that the system is running efficiently. But is it? How much of that water is going to where it's supposed to go? Or how much of it is just silently sliding down the street, doing nothing? Stick with me for a few minutes, and we're gonna show you some results of what distribution uniformity means to an irrigation system and what it can do to help you get your system running more efficiently. All right, this is the existing system as it was installed. It's a fairly new system. 3-4 years old now. All right, got 15-foot gaps. We've got a full. We've got the side strips on the other side of the sidewalk. Some of the nozzles are called bands, variable adjustables. And then we've got a mixture of that with some stick sprays. Okay. Test number one. We're running a distribution uniformity test on an irrigation system here in North Houston. What we're doing is we've set up catch cups, 2-foot offset from all the sprinkler heads. We're running the system with the existing contractor setup in place, 4-inch heads, standard nozzles that are used. Test number one, we're going to determine how much water has been used and how much is getting to where it needs to go for proper distribution and proper coverage. All right, moving into the actual test, we can see we tried to minimize the overspray as much as we could with these nozzles, but it's hard with some of these. We've got some interesting things going on right now. In terms of how much water is getting into these cups. We also have the issue of absorption. We've got a lot of standing water. Okay, test number one was ran for 5 minutes. We've documented how much water was in each one of these test cups, or the catch cups. Now that we've documented that, we're now going to replace each of the nozzles on the head. As we get into this, we're going to replace this piece right here with the Toro high efficiency spray nozzle, the precision spray nozzle is what we use. And then we're going to rerun the exact same test using those new high efficient nozzles. Huh. I think this head was compromised.
Oh, it's cross-threaded?
It was cross-threaded. Okay, test number 2. We've swapped these out for Toro PSN Plus nozzles. The Plus nozzles are their recent addition with a little, basically a check valve inside, so it prevents water from, when the system's turning off, it prevents water from pulling dirt back into the nozzle. So we're now running the whole system on PSNs. You can see right off the bat that it doesn't look like the same amount of water flowing out, and there isn't, which is one of the whole points of the efficiency side of this. Okay, running the side strips. You'll see very little water is getting onto the concrete now. Should be able to walk through there without getting wet. Test number 3 is we're going to take it to the next level of efficiency by swapping out the contractor grade 4-inch heads, and we're going to put in a pro grade Irrigation 6-inch head with a check valve in it. The check valves are used to prevent water from leaking out of the heads when the zone is turned off. But by getting those heads 2 inches higher above the grass, what we should see is an improved efficiency, even more than just the straight nozzles.
All right.
Well, don't worry, my dirt. Just finished up test 3. We've swapped all the heads. There was 12 heads we swapped out, 13 heads that we swapped out for the 6-inch, and we put the same PSN nozzles on them. Just ran the test. Same amount of water was used. We'll confirm that in the numbers, but going to just the volume of water across all the cups, a lot more consistent. So I'm anxious to see the math on that. But in general, what we now have is a much more efficient zone here that puts the water down more efficiently without as much water. And now we can do proper irrigation time calculations and make sure we're getting the right amount of water for what's needed here. Mission accomplished.
Good evening. Glad you could join me out there. It was a fun little field exercise. I'd like to spend a minute though talking a little bit about how I came up with those numbers. Showed you that chart. It's got a DU number, 0.3, 0.55, 0.64. Well, what does that mean? How did I get that? So we'll take a step back and understand why DU, why distribution uniformity. When you irrigate your yard, we're looking for areas that are dry. What's the driest area in that yard? If it's too dry, what do? We bump up the watering time. Try and get more water there. It's obviously not being watered enough. If we look at distribution uniformity though, that tells us how much water is getting to that area in terms of a percentage. So when you think about it, the lower the DU, the higher the run times are that you need to get water to those dry areas. The higher the DU, the less amount of time you need to get water to those driest areas. So that's what the DU tells us. It gives us a percentage of how much of that water is coming out of that spray head and getting to those areas that it needs to get to. So there's an equation that's used to do that. It uses an equation, it uses the average of the lower quarter divided by the total average of all the measurements. And so the lower quarter, what that means is if in our case we had 24 catch cups, so a quarter of those is 6, we take the lowest 6 measurements, average those, and then divide that by the total average of the whole system of measurements. Why does that matter? Because that average LQ is a function of that issue of is what's the driest parts? What area is getting the least amount of water? Because it's the least amount of water in that area that's going to drive those run times and keep them going up and require us to keep our systems on longer. So when we look at that, I've got it all tabulated in these columns from our readings. The first column is cups in sequential order, and then I sorted them by the lowest to the highest numbers and took the bottom 6 for our lower quartile. So that's where the equations comes from. So when we run through the baseline DU, we look at the lower quarter at 6.83, and we divide it by the total amount, the total average of those, which ended up being 22.67. Look at my notes here. So we come up with a 0.301 DU, or 30%. Same with test 2. The lower quartile average, the lower quarter average for test 2 was 11 milliliters, and the total average was 20.13. So when we make that equation and come up with our average, it's 0.547. And then for our test 3 with the 2-inch higher heads, the lower quarter average is 15.5 with over an average of 24.13. So even just looking at that lower quarter average, you see how much more water is getting to those areas by using the PSNs and then by increasing the head height by 2 inches. So that's how we come up with the DU number. Now, ultimately, what does this tell us? It tells us that with the right nozzle, in this case a precision spray nozzle, we can actually get more water to those dry areas in less amount of time, therefore using less water. So the Toro PSN, by its nature and its design, is using less water already, which we see. So that's the other component I wanted to talk about is not only are we seeing an improved distribution of that water, getting the water to those dry areas, but when we look at the average amount of water saved just by using those nozzles, it's pretty incredible. So when we look at the baseline test, if we actually look at it from the perspective that most of the systems in the Houston area, call it probably on average, they have about 6 spray zones on average in the typical residential home. Most people run those spray zones 10 minutes per cycle, 3 times a week. And I'm assuming a 44-week irrigation season, typically shutting the systems down to 8 weeks a year type of thing, maybe a little bit longer, but let's just assume 44 weeks of operation. Most people don't adjust their watering times throughout the season, so it's 10 minutes every cycle, 6 zones, 3 times a week for 44 weeks. So when you actually look at the amount of water you use during that period of time over a course of a year, what does the baseline tell us? The baseline tells us that using those variables over the course of a single season, that system is going to use 182,000 gallons of water, which is a lot of water, depending on which mud you live in and what your transfer fees are and all the distribution fees, and that can turn into a lot of money. By contrast, if you simply put the PSNs on your system, even if you don't worry about the 6-inch heads, just put the PSNs on, that same usage, same variables, 44 weeks a year, 3 times a week, 10 minutes per cycle, 6 zones, your consumption goes down to 110,000 gallons or 111,000 gallons, approximately, if we round it. So just by that one simple change from your nozzles to the PSN, in terms of a high efficiency upgrade, you'll save a little over 71,000 gallons of water in a single year. Translate that into whatever your water bill is. It can be anywhere from a couple hundred to multiple hundreds of dollars of savings by that simple upgrade. And then the kicker is once you've done that upgrade, it's done. Yet water is going to continue to increase in price every year, and it's going to continue to be the most costly part of your irrigation system as far as a component, and that's the water price. So thank you for sticking with me through this little exercise. Hopefully I didn't bore you to tears too bad. For me, it was interesting to see how the science and the math come together. Obviously, at Conserve Irrigation, we promote the Toro products, the Toro PSNs. We use the Toro T5 rotors, but then we also use the Hunter MP rotators quite extensively as well for those larger lawn areas. Stay tuned because I'm going to be running similar tests with the rotors and the MP rotators to see what the math tells us. In the meantime, if you'd be interested in learning more about your own system, understand the efficiency of it, how can we help you get a healthier lawn by decreasing your water time through higher efficiency irrigation. We'd love to help you. Give us a call or shoot us an email. I'll post that here shortly, and thanks again.